Welcome to another EncellaDome video, the channel helping you get smarter one video at a time by widening your perspective about the world around you. In 1966, the Lunar 9 spacecraft became the first robotic spacecraft to land softly on the moon. Just about 3 years later, in 1969, the Apollo 11 spacecraft became the first manned mission on the moon. Now contrast that with the fact that the first robotic missions to land on Mars were all the way back in the 1970s. It's been over 40 years, close to 50 years now, and at the time that this video was being shot, humans are yet to land on Mars. So what makes landing on Mars so much harder than landing on the moon? And if we did manage to get there, how easy would it be for us to survive? Those are some of the things that this video is going to address. Getting to Mars is extremely difficult. If anything, only about 40% of all the attempted missions have been successful. But if you did want to get there, the first hurdle that you would face would be the distance between Earth and Mars. In theory, the closest that Earth and Mars would approach each other would be when Mars is at its closest point to the Sun and Earth is at its furthest. This would put the planets only 54.6 million kilometers apart. However, this has never happened in recorded history. The closest recorded approach of the two planets occurred in 2003, when they were only 56 million kilometers apart. The two planets are furthest apart when they are both at their furthest from the Sun on opposite sides of the Sun. At this point, they can be over 400 million kilometers apart. The fastest spacecraft launched from Earth was NASA's New Horizons mission, which visited Pluto back in 2015. In January 2006, the probe left Earth at a speed of 58,000 kilometers per hour. If such a probe traveled in a straight line to Mars, here's how long it would take when the two planets are at their closest and at their furthest. At their closest distance, it would only take 39 days, and at their furthest distance, it would take 289 days. So on average, it would take about 162 days. But then things get complicated from here. These calculations assume that the distance between the two planets is a straight line. The numbers also assume that the two planets will remain at a constant distance from the time a probe leaves Earth to the time it reaches Mars. In reality, the two planets are continuously moving in their orbits around the Sun. Engineers must calculate the ideal orbits for sending spacecraft between the two planets. Their numbers factor in not only the distance but also the fuel efficiency. Like throwing a dart at a moving target, they must calculate where the planet will be when the spacecraft arrives and not when it is leaving the Earth. Engineers must plan to make sure that by the time the spacecraft reaches the distance of the Martian orbit, Mars will be where they need it to be. This essentially entails that you can only begin your trip when Earth and Mars are properly lined up, and this only happens about every 26 months. Considering a spacecraft carrying humans to Mars would carry lots of equipment, life support systems, plus food and water to last the whole trip, it would be much heavier than New Horizons was, so it wouldn't be able to reach the same speeds that New Horizons was capable of. And with present rocket propulsion technology, this spacecraft would probably take about 6 to 8 months just to reach the red planet. The good news is that evolving rocket technology can help shorten this flight. For example, NASA is presently working on the Space Launch System, SLS, and SpaceX is also working on their Starship. These will be the new workhorse vehicles that will hopefully take humans to Mars one day. If you somehow manage to make it to the surface of Mars, you will then be faced with 3 new related problems. These are the atmosphere, climate, and weather. Stepping outside on Mars without a spacesuit is not an option. The atmosphere on Mars is about 100 times thinner than Earth's and contains 95% carbon dioxide, so breathing would be extremely difficult if not impossible. but the atmosphere is still thick enough to support weather, clouds, and winds. Early in its history, Mars had a thick enough atmosphere for water to run on its surface. Orbital pictures show vast river plains and possible ocean boundaries, while several Mars rovers have found evidence of water-soaked rocks on the surface. However, for some reasons that are still poorly understood, the Martian atmosphere thinned. The thin atmosphere and its greater distance from the Sun means that Mars is much colder than Earth. The average temperature is about -60 degrees Celsius, although it can vary from -125 degrees Celsius near the poles during the winter to as much as a comfortable 20 degrees Celsius at midday near the equator. And things only get worse. Giant dust devils routinely kick up the oxidized iron dust that covers the Martian surface. Dust is also a permanent part of the atmosphere, with higher amounts of it in the northern fall and winter and lower amounts in the northern spring and summer. The dust storms on Mars are the largest in the solar system, capable of blanketing the entire planet and lasting for months. There are times that it snows on Mars. The Martian snowflakes are made of carbon dioxide rather than water and are thought to be very small particles that create a smoke effect rather than appearing as falling snow. The North and South Pole regions of Mars are capped by ice, much of it made from carbon dioxide instead of water. Let's talk about the Earth for a moment. The Earth has something called the magnetosphere. The magnetosphere is the outermost and largest layer of the Earth's atmosphere. It is caused by the Earth's magnetic field, and it is a very important layer that protects the Earth's atmosphere against the ionic radiation radiated by radioactive elements such as uranium. Without it, all human, plant, and animal life on Earth would die immediately. Almost all the planets in our solar system have a magnetosphere, except for Venus and, incidentally, Mars. For us to understand why the lack of a magnetosphere on Mars would be such a big problem, let's look at some of the functions that the magnetosphere serves on Earth. Number 1, it protects water in the atmosphere and oceans by preventing the dissociation of hydrogen and oxygen atoms. Number 2, it prevents the malfunction and interruption in radio, radar, or satellite equipment. Number 3, it produces the magnetic poles that are used for orienting humans and some animals. Number 4, it protects our planet from the radiation of solar particles and some cosmic particles, and also protects the atmosphere from erosion caused by the solar wind. The reason Mars does not have a magnetosphere while Earth has one is that the core of Mars is solid while that of the Earth is molten. It is the continuous movement of the molten ion at the Earth's center that generates this magnetic field. So without a magnetosphere on Mars, there isn't enough protection to protect animals and plant life from the solar wind and cosmic particles, and as a result, early settlers would have to live on underground cities in order to stay away from the radiation. As if we do not have enough problems already, we would run into another problem, and this is a low gravity. The gravity on Mars is slightly lower than that on Earth. At first, this wouldn't seem to be such a big problem because a lower gravity would mean you weigh less than you do on Earth, you can lift heavier objects, and at the same time you can jump much higher than you would if you jumped on Earth. The first problem that will be caused by a lower gravity will be muscle atrophy. In the absence of the usual amount of gravity, there is no weight load on the back and leg muscles, so they will begin to weaken and shrink. In some muscles, the degeneration will be much more rapid, and without regular exercise, astronauts would start to lose a large percentage of their muscle mass within the first days of arriving on Mars. The second health problem as a result of a low gravity is osteoporosis. This is a loss in bone mass. Due to the lack of mechanical pressure on the bones, bone mass is lost. The mass loss mainly affects the lower vertebrae and the spine, the hip joint and the femur. Due to the rapid change in density, bones may become brittle and exhibit symptoms like those of osteoporosis. The last reason why settling on Mars would be quite challenging is that there just isn't enough of a self-sufficient ecosystem. For example, there's no liquid water on the Martian surface, so you'd need to carry your own water for use in the initial days, though later on you can access water from the frozen ice at the poles. Secondly, there is no animal or plant life that you can use as food, so you'd need to carry enough food to last you the first few months while you're trying to set up greenhouses or some kind of ecosystem. As we have seen, there are several challenges that are hindering human travel to Mars and its eventual colonization, but that shouldn't stop us. Scientists are actively trying to find ways of transforming Mars into an Earth-like environment and making it more livable. We are going to look at some of these proposed ideas in a future video. If you love books but can't seem to have enough time to read, then try AudioBooks. It's a service that allows you to download audiobooks of your favorite titles, and you can enjoy these on your iOS, Android, Sonos, Kindle, and Alexa-enabled devices. If you have multiple devices, whenever you switch to a device, you can pick up wherever you left off on the other device. Start your 30-day free trial and get 1 audiobook plus 2 Audible originals. If you don't like the audiobook, you can swap it for free. After the trial period, membership is only $14.95 a month, and you get 1 audiobook and 2 Audible originals each month. Check out the affiliate links in the video description to start your free trial today and get a 30-day commitment-free guarantee. If you would like to advertise your products or services on our platform, then don't hesitate to contact us. You can send us an email or you can directly message us on our Facebook page, and we'll be able to get in touch with you and find out how best we can help your business grow. If you like what we do here and would like to sponsor us so that we can continue producing educative content like this one, then consider becoming a Patreon by going to patreon.com/EncellaDome and become a Patreon so that you can keep us financially healthy. We've come to the end of the video, and thanks for watching. Please like, subscribe, and share this video with your friends so that they can also benefit 1 or 2 things.